Differentiation is a fundamental concept in calculus, a branch of mathematics that deals with the study of change. In particular, differentiation is concerned with understanding how a function output dependent variable changes in response to changes in its input independent variable. The derivative is the key concept in differentiation. The derivative of a function represents the rate at which the function is changing at any given point. Geometrically, it corresponds to the slope of the tangent in line to the graph of the function at that point. There are various techniques for finding derivatives, and this depends on the type of function you are dealing with. Some basic rules include the power rule, product rule, question rule, and the chain rule. These rules provide a systematic way to find the derivatives of different types of functions.
There are three basic rules in differentiation. Firstly, we have the power rule. Power rule is when we subtract 1 from the powered number of the original number, and the original powered number will be multiplied with the original number. Secondly, we have the product rule. Product rule is used when there is a multiplication in the equation. Third, we have the quotient rule. Quotient rule is used when there is a division in the equation. Fourth and last, we have the chain rule. Chain rule is when you differentiate outside and also inside the bracket, and the differentiation of outside and inside the bracket is multiplied together. So from here, we know that differentiation helps us to analyze how things change, and it's used in various fields like physics and economics for understanding rates and change, and for change and optimization. Now moving on to our problem statement, we can see from the figure over here, it shows a closed small cylinder can with radius of r centimeter and height of h centimeter that is placed on a larger cylinder. The radius of the large cylinder is 2r centimeter and height of 2h centimeter.
For question A, if the surface area of the both cylinders are 350 pi cm square, express h in terms of r. The surface area of a cylinder is given by the formula 2 pi rh plus 2 pi r square. Therefore, the total surface area of the larger cylinder is 2 pi times 2r times 2h plus 2 pi times 2r square, and the total surface area of the smaller cylinder is 2 pi rh plus 2 pi r square. At the same time, for larger cylinder, we need to minus 2 pi r square because the smaller cylinders cover a small part of the bigger cylinder. And then, solve and simplify the equation until it becomes 10 pi rh plus 8r square equals to 350 pi. Next, we factorize the pi and cancel out them. After that, bring 8r square to the right side, so it will become 10rh equals to 350 minus 8r square. Lastly, leave only h in the left side, so the rest move to the right side, and we will get the answer, which is h equals to 350 minus 8r square divided by 10r.
So, for the next question is, show that the volume of both cylinders is given by V equal to 315 pi r minus 7.2 pi r cubed. As we know, the general formula for the volume of cylinder is V equal to pi r square h. So, from the figure shown, we can consider that the biggest cylinder as V1, meanwhile the smallest one as V2. So we calculate the first volume, which is pi multiplied with the radius, which is 2r square, and for the height, which is 2 multiplied with 350 minus 8r square over 10r. So we simplify the pi, and we will get 4 pi r square multiplied with 350 minus 8r square over 5r. And we simplify again, and we will get 1400 pi r over 5 minus 32 r square over 5. So we move on to the next volume of cylinder, which is V2, equal to pi multiply with the radius, which is r square, and multiply with 350 minus 8r square over 10r for the height. And we simplify and we will get 350 pi r over 10 minus 8 pi r cube over 10. So to know the volume of both cylinders, we must to summarize the volume for the first and the second one. So we will get 1400 minus pi r over 5 minus 32r square over 5. We have to plus with the second volume, which is 350 pi r over 10 minus 8 pi r cube over 10. And the final answer we will get the volume is, which is 315 pi r minus 7.2 pi r cube. So we can prove that the volume of both cylinders is the given answer.
For question C, which is determine R in centimeters so that the volume is maximum. Hence, find the volume of both cylinders. This is where we apply the critical value in differentiation. We use dr over dv because the question is focused on radius. So we differentiate the original equation for volume. So we will get 315 pi minus 21.6 pi r squared. And since we want to find the critical value, or in this situation we want to find the maximum, we equal the equation to 0. So 315 pi minus 21.6 pi r squared equals to 0. Then we move the 315 pi towards the right hand side because we want to know the value of r. So negative 21.6 pi r squared is equal to negative 315 pi. Then we factorize negative 21.6 pi from r squared. That's why we get r squared equals to negative 315 pi over negative 21.6 pi. From here, we can already cancel out the two negatives and the two pi's, which will leave us with 315 over 21.6. Then, since there is a square on the r, we will move the square to the right hand side, which will turn into a square root. So r equals to square root of 315 over 21.6. Then that's where we get our answer, which is r equals to 3.852 centimeter.
In conclusion, differentiation allows us to dissect complex functions, uncovering their behavior at specific points and over entire intervals. Through the lens of derivatives, we can insight into slope, concavity, and extremities of functions, providing an understanding of their underlying structure, the application of differentiation far beyond mathematics. So, we can conclude based on our study, differentiation can improve our problem-solving skills, plus it helps to discover the simplest and the easiest mathematical principle for our learning purposes. On top of that, the study of differentiation in calculus opens to understanding the intricate relationship between any variables and their rates of change from various types of questions.